Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here the product design in part second. In that we will discuss the creating toolpath in CAM environment using Autodesk Fusion 360. So first of all, we look at the geometry for this component. So here we have to form two operations, that is 2D pocket and 2D counter. As we know that the 2D pocket is nothing but roughing operations with option for creating a finish fast. So here we can clear the cavity which is inside the that component, and here we have to clear the inside boundary, that is nothing but 2D pocket. The next operation is that is 2D counter. So with the help of 2D counter we can remove the outside of the boundary. So this is regarding the operations. So here we have to create a toolpath and export the NC code for CNC machining. So first of all, we create this geometry into the Fusion software. So we enter into the Fusion software first. So here create sketch, then select the plane, then we select the this that rectangle, and according to our application we can select the sizes. Then again we can create another rectangle like this. Then again go to the modify command for fillet purpose. So you can give the fillet directly like this. This is third fillet and last it is fourth fillet. So here we are to forming the fillet. Now you take the finish sketch, then go to the extrude command, select this outside the boundary, and we have to lift it for 25 mm. Say okay. Now next again go to the that sketch mode, then we pan it first, then go to the escape, then again go to the extrude command. We select this middle portion and we have to lift it for, I can say extrude for 5 mm, and then say okay. So this is regarding the geometry of this component. Now next we enter into the CAM environment. So here we have to change the workspace from design to manufacture. So in that content we have to look at the different features related with the operations. So after that we have to enter into the setup operation for performing the different toolpaths. So here first of all we select the machine. So as per our requirement, or I can say as per our availability, we can select the machine. Then you have to select the setup. So in that setup you have to select according to our application, that is if it is milling is there you can select the milling setup. If it is turning is there you can select the turning setup. So likewise you can select setup. Then next term is that is work coordinate system. So you have to select the XYZ plane according to our requirement. Then stock selection. So it is having extra material, you can remove it. So this is the selection procedure we have to carry over here, that is in setup. So first of all we enter into the manufacturing workspace. So here manufacturing workspace is there. Then you select the manufacturing workspace. Then nextly that is we go for setup, that is new setup. So this new setup you enter it and then select the machine mode. So different machines is available with us. So if you select additive manufacturing, so additive manufacturing operations, or you can say additive manufacturing machines available with us like this. Then if you cutting, if you deselect and cutting is there, then select cutting operations machine is there. For milling machine is there. Then for turning purpose, turning machine is available with us. So likewise we can select one. For milling machine we can select, and here we select the generic 5-axis AC head to head. Then select one. Then next setup. So after completion the machine setup, go to setup. Here the milling operation is there, so you can select milling. Then next for model orientation, so instead of Y you can select here Z. So that is why you select Z axis and X axis. So select this axis and this. Sorry, this is this X, okay, and Y. Okay. So after the selection, it can select Z axis and Y axis. Then nextly, that is, we can go to the box points. So here tool is available with us, right? So here we can select like this. So here tool will be approach it. So like that setup we can do here. Only we are required here Z axis setup. So here Z axis. Okay. Likewise you can select Z axis is on a that perpendicular manner. So that's why we have to select these spaces. Now we enter into the stock moment. So here we have to select the relative size box for adding the some material. So we can add like this. So here the material you can add like this. Okay. Then next the so this here we can complete the operations. Say okay. So this is again in the setup. The next slide indicate that the different operation. So first of all we enter the cam, then go to the setup mode. The next mode is that is 2D pocket. So before that we have to go different operation, that is 2D pocket and 2D counter. So first of all we select the 2D pocket one. So here 2D operation with 2D pocket, right? Then select the tool. So for selection purpose we are having different operations like pocket, open pocket, face, counter, threading, slot, engrave, then 3D profile, horizontal, circular, chamfer, probing. So likewise operation is in milling here. For hole making, that is nothing but drilling. So hole we can select. For turning operation, general, grooving, boring, threading, according to our requirement we can select anyone. So here we require pocket, so we can directly get opaque pocket. Say okay. Then type is there, so according to our requirement we can select the face. So I require flat, so all deselects and only flat will be select. Say okay. Then this tool will be import from this tool metric. So if you required 60 mm, so according to your research you can select 60. And if you require changes, so you can change dimensions. If you check the dimension, suppose you want to change in this dimension, so require 20, so you can write 20. So likewise you can change. So select OK. So this is the overall information of the tool, both that is body material, tool grade, then geometry. So likewise the that information is there. Then say OK. So here we have create the path. Say OK. So pocket is not selected, that's why not operation is there. So operation is selected. Say OK. So here select the geometry. Therefore the pocket operation is completed. The next operation is the this is 2D pocket, already we covered. Then 2D counter. So for 2D counter we have to select 2D counter operation. So here 2D counter. So 2D counter is selected here. Then next select the tool. So for operation mode, so this is regarding the pocket, or you can say open pocket. Then say OK, and then next enter into the tab, that is according to our usage. You can select any one tool. Say OK. Then next we enter into the that tutorial sample, or you can say tutorial metric. So you can select any one of that. Okay, 60 mm is there, so 60 mm select over there. Say OK. Then select this face and then OK. So this is regarding the 2D counter. So this is regarding the tool selections procedure, right? If you enter in a 60 mm flat, suppose we have to change here. So directly can click and change this operation that selected to. So likewise edit mode is also available with us. Then say OK. So first of all we simulate this path. So in next slide this is simulation. So how to generate for 2D pocket first action. So here we select first 2D pocket action generate yes. Then next action simulate. So here we can simulate this, then it can remove this material easily. So this is the finished part. So here regarding the information that X position, Y position, Z position, spindle speed, feed rate. So likewise the information there. So which operation or which machine is there. So here generic 5-axis AC head. So initially I selected here verification if it is collision is possible or not. So here operation is none. Then volume, start volume. So this gives the value. So start volume is 273 and after that it should be 173. So it can remove the material, right? So this is verification and the statics mode. So it is machine time. So this is we have to calculate the machine time from this end also 1.59. So this is the time. Then machining distance operation tool changes. So only one tool changes there. So this is regarding the 2D pocket. Now we enter in for 2D counter. Again you go to the action mode, generate, yes, then action, then simulate. So after that we can simulate this. So we can remove this material easily. So this is 2D counter. Say OK. So here also you can check out the information. So this is the position for x-axis, y position, z position, description, machine which we have used here, then operations, which operation description is there, so which tool is there, that is fine diameter 60 mm, second operation, then that's why it can write it as a #2, then initial volume, final volume, then distance, then statics we will check here. So one, not 44 seconds, 44 seconds. So according to your changes you can enter here. So here also we can calculate the machine time. So machine time we can calculate easily and say close. So if you required in any one stroke, so first of all we raise the shift, then select these two modes, first one and second one, then again go to the generate, yes, then go to the generate mode and simulate. So first we'll see the 2D pocket and then we go for 2D counter. So this operation is 2D pocket, right? So 2D pocket is there. So this is regarding the toolpath generation. So when this tool enter into the that mode, so suppose this mode, so that time it indicate line the yellow, and it can, if it is a rapid traverse is there, so it can indicate line the that red. So this is regarding the uh, simulation for counter. So close it. Then next mode is for, so here we check out first, that is simulation. Then now we enter into the post process. So here in the post process we enter action mode, then post process. So here we can convert the machine language into specific NC code, right? So this is post process. So here we have to select different machine code, different machines name. So Kosi is there, then Mozak is there, then Mac 3 min is there, different machine is available with us, that Pocket Instance is there, Silka is there. So according to our usage you can select. So I select here that Haas UMC 750 is mostly used in industries, that's why I selected this. Now post it. So here post it, so you can give the name for that, so anyone can give the names. So save it. So this is the toolpath generated over here. So this is first that operation is there, so using high speed feed G1 is there, then 2D pocket operation, This is tool path generated over here. Then next 2D counter is there. So this is the operations coding is there. So this is called as post process, and this code is export. This is export method for receiving the NC code, and then we have to put it into CNC machine, and then we can formulate our product. I can say convert into our final product. So this is regarding the post process. So here we have to see the programming code. So it is generated in that CAM software. So here we are studied here different points, that is regarding the 2D pocket, 2D counter. So how it select the CAM environment, then how to set up the machines, then set up for that operations, then work coordinate system, then stock selection, then next operation on component. So this operation for that you can select the tool, that tool for that different speeds, then variety of this diameters. According to that requirement you can select these tools, then you can simulate the 2D pocket for that of ANC codes, then we are simulate for 2D counter here. So likewise you have to simulate over here, and then last final, that is operation, that is post process. So here you have to export the that code, that is the G code, or you can say machine code, into our NC code. So this is regarding the process, and this is the NC program. So here we have developed NC program. So likewise, and here in a Fusion it can create, suppose we edit mode is also there. Suppose you required in changes in the speed, so it changes in the speed. You can change the ramp feed up rate, plunge feed up rate, so it can change easily, right? Can say okay. So this is edit mode also available with us. Right click, edit mode is there also. Say okay. Suppose if you require delete operations, we can delete directly. So likewise you can check all the qualities. So this is the tool path generated for this particular geometry. Thank you.